What's happening, guys? My name's Nicholas Renat, and welcome to the very first episode of Papers to Code. In this series, what we're going to be doing is building our very own facial recognition app using deep learning from scratch. So this series is all going to be to do with grabbing the data, building up the model, and implementing it inside of an application. Ready to do it? Let's take a deeper look as to what we'll be going through. So in the very first episode of this bigger series, what we're going to be going through is just our general setup. So what we'll do is we'll install our dependencies. We're going to import all the different Tensorflow, specifically deep learning components that we're going to need. This includes our layers, our models, and our inputs. We're going to also configure our GPU. So if you're using Colab or if you're using your local machine, this is going to ensure that you don't blow out your GPU completely. And then what we're going to do is we're going to set up our data folder. So there's going to be a bunch of episodes following this. So this is really just the setup. Ready to do it? Let's get to it. Alrighty, guys. So we're going to keep this pretty simple and easy, at least for the first episode in the facial recognition or face ID type series. So what we're going to be doing in this episode is we are going to be installing our dependencies, importing our dependencies, setting our GPU growth, and then creating our folder structures. Now, what I'm hoping is that this sort of episode or this style of video is going to become a little bit more common on the channel. So we'll be able to take papers and convert them to code and actually implement them with practical examples. So if you like this style of series, do let me know in the comments below. I'd love to hear your feedback. So what we are going to do in this particular case is, first up, we're going to install our dependencies. Now, the first part of this series is going to be all inside of Jupyter. So this is all going to be the data science and deep learning side of things, where we actually create our facial verification model. And we'll talk a little bit more about the paper that we're actually going to be interacting with a little bit later, but we'll see that. And then once we've gone and done that, we'll actually transition and start coding up in VS Code for when we go and build our facial verification app. So first things first, let's go on ahead and install our dependencies. Alrighty, so those are our dependencies now installed. Now let's actually take a look at the line of code that we wrote. So first up, we wrote !pip install. So this is your standard Python install. And as per usual, we're going to be taking this entire tutorial step by step. So again, we're going to write the code and explain it. So !pip install TensorFlow equals 2.4.1. So this is going to install the TensorFlow 2.4.1 version into our environment. Then we're using, or we've imported or installed TensorFlow-GPU equals 2.4.1. And if you don't have a GPU on the machine that you're running on, there's a few things that you can do about it. You can try running this tutorial again without a GPU, but it's going to be a little bit slower to train. So, which is perfectly fine. It'll still work. If you want to use a GPU, there are a whole bunch of cloud platforms out there that leverage Jupyter Notebooks. So Colab is a free one that you might take a look at. But in this case, if you don't have a GPU, it's perfectly fine. Then we've installed OpenCV. And so in order to do that, I've written OpenCV-Python. And this is going to give us some of our image processing capabilities. And we're really going to be using this when we actually go to do real-time testing right at the bottom of this tutorial. And then we've gone and installed matplotlib as well. Cool. So all up, we've installed 4 different dependencies. So !pip install TensorFlow 2.4.1, TensorFlow-GPU 2.4.1, OpenCV-Python, and matplotlib. So those are our 4 dependencies now installed. Cool. So that is part 1.1 now done. Now the next thing that we need to do is import our dependencies. So we've sort of got 2 different classes of dependencies that we want to import here. So we've got our deep learning stuff, so all of our TensorFlow components, and then we've got some sort of standard dependencies that are more going to help us actually work with our data. So let's go on ahead and import our standard dependencies first, and then what we'll do is we'll import our TensorFlow dependencies after that. Okay, those are our standard dependencies now imported. So I've written 1, 2, 3, 4, 5 lines of code there and 1 comment. So the comment just says we're importing our standard dependencies. Again, it's good practice to comment your code. So what I've written is import CV2. So this is going to import OpenCV into our notebook. Then we've imported OS. So this is just an operating system library, and we are going to use this when we actually go and create our folder structures. So this just abstracts the operating system from our Python code. So it just makes it a whole heap easier to work with different directories, different file paths. Then we've imported random. This one is a little bit optional, but I've brought it in just in case. So if we are testing, generating new data, this comes in handy. Then I've imported NumPy. So import NumPy as NP. And NumPy is a great library when it comes to working with different types of arrays. So Tensorflow, which is the deep learning library we're going to be working with, is all to do with different tensors or working with different tensors. NumPy helps us work with those. So what we're then going to do is import matplotlib, and NumPy is really just a really great array transformation library. So again, if you need to resize or reshape arrays, comes in super handy there. So we'll probably use it later on. Then we've imported matplotlib. So from matplotlib, import pyplot as PLT. The main reason that I've brought in matplotlib is because there is a method called plot.imshow. So if I type in plot.imshow, this effectively allows us, and question mark, this effectively allows us to visualize an image. So you can see there it says display data as an image. So it just makes it super easy to visualize it when we're working with our different data components, which we're going to need when it comes to facial verification. Cool, so that's done. All right, so we've gone and written those 5 lines of code. So import CV2, import OS, import random, import NumPy as MP, and then from matplotlib, import pyplot as PLT. Cool, so those are our standard dependencies are now imported. Now the next thing that we're going to go on ahead and do is import our TensorFlow dependencies. So I'm just going to change this. So we're going to import TensorFlow dependencies. And really, we're going to be using, well, not really. We're going to be using we need to import 2 key things here. We need to import our model components and the different deep learning layers that we're going to need. Now, what we're actually going to be doing is we're actually going to be using the TensorFlow functional API. So a lot of tutorials tend to use the sequential API, but what I've actually found is the functional API is a lot more flexible when it comes to building really hardcore deep learning models, which in this case, this one actually is. Now, the model that we're going to be building is called a Siamese Neural Network. So this actually allows us to do something called one-shot classification. We can actually pass through 2 images and determine whether or not that image is the same. So if I actually bring up that paper, let's see if I can bring it up, and I'll link to this in the description below as well. So basically what we're actually going to be doing is we're actually going to be building up this network described in this paper. So Siamese Neural Networks for one-shot image recognition. And if you actually take a look at the architecture here, so this is really important. So we are going to have 2 inputs. So you can see that there is a break between these hidden layers here. So we've got this input and we've got this input. What we're effectively doing is we are passing through 2 images at the same time, and then we're going to have this distance layer. So this actually measures the similarity between the 2 images. And we're going to train our neural network to determine what that similarity is like. So if it is very similar, then we're going to output a 1, which basically means it is verified. If they are completely different, then we're going to output a 0, which means we are unverified. Now, in terms of the neural network that we're going to be building, we're effectively going to be implementing this or something very, very similar to this. I think the input shape that we're going to be passing through is a little bit different. We'll have 100 by 100, but you will see that towards the end of this series. So we're actually going to take this model and actually implement it in real time, which is super cool. All right, we've digressed. So this is the model that we're going to be building. We're going to be using the TensorFlow functional API, and I will link to this in the description below. But for what we need to do now is we actually need to import those functional API components, so functional API. So let's go ahead and do that. Okay, those are our functional API components now imported, and we've also imported TensorFlow as well. So let's take a look and take a step back as to what we've actually gone and imported. So what I've written is from tensorflow.keras.models, import model. This is probably one of the most important layers that you're going to need. So when you're actually defining your model using the functional API, what you effectively do is you type in model, and you pass through 2 things. So you pass through inputs and then you set that, and then you also pass through outputs and you set that. So what we're effectively going to be doing is we're going to be building up our neural network and then passing through what we want our inputs to be and our outputs to be. So this is slightly different to the sequential API, but it allows you to define a significantly more sophisticated neural network. So ideally what we'll actually have is we'll have our input image. Let's put this in brackets, our input image, and then our verification image. And what we're effectively going to get out is a layer which effectively outputs 1 or 0. So that is effectively what our model is going to look like by the time we actually get to it. So that is what the model class is used for. So in order to do that, I've written from tensorflow.keras.models import model, and this is effectively giving us this. And then a big part of our deep learning models are a whole bunch of different layers. So in order to do that, we've imported a bunch of different layer types. So we've imported, or we've written from tensorflow.keras.layers import layer. So this layer class is a high level class. So this actually allows us to define a custom layer. Now, when it actually comes to doing that, we can effectively create a whole new class to actually go and generate that layer. So it's effectively class L1, or the class that we're actually going to be implementing is going to be called L1 distance. And we can actually pass that layer through, so we can perform inheritance for that layer. So this effectively allows us to create a custom neural network layer. So we'll actually be going through some really cool concepts as part of this bigger series. Okay, so we've imported from tensorflow.keras.layers import layer, and then we've actually gone and imported some standard layers. So conv2D, this allows us to perform convolution. So if you've heard of convolutional neural networks, that is exactly what that allows us to do. We've imported dense, so this gives us a fully connected layer, which is effectively what you typically see in most neural networks. So it sort of looks like these layers that you're seeing here. We've then imported max pooling, so this allows us to pool our layers together and effectively shrinks the information that we've actually got. So this is almost like averaging, or in this case, it's not averaging, it's actually taking the max values over a certain region to effectively reduce how much data we're actually passing through to the next layer. And then we've got our input. So this is, again, another base class. So if you think about the three most important classes we've got here, it's model, layer, and input. So our input allows us to define what we're passing through to our model, and our layer effectively, or our model actually allows us to compile it all together. And our layer gives us our base class. And when we're defining our input, we're effectively typing in input and then shape, and you're specifying the shape there. And then the last layer that we've imported is flatten. So this effectively takes all the information that you've got from a previous layer and flattens it down into a single dimension. So that allows us to pass convolutional neural network data to a dense layer. So that's what we're going to be using that for. And then we've imported TensorFlow as TF. So import TensorFlow as TF. So let's quickly recap on what we've imported. So from tensorflow.keras.models, import model. From tensorflow.keras.layers, import layer, comma, conv2D, comma, dense, comma, max pooling 2D, comma, input, comma, and then flatten. And then we've imported the TensorFlow base, or the TensorFlow class overall, or TensorFlow overall. So import TensorFlow as TF. So we're going to use this for our image processing and a whole bunch of other helpers. But that is section 1.2 now done. So what we can actually do is delete this because we don't need that, and we can delete that. So that is section 1.2 now done. So what we can now do is go on ahead and set our GPU growth. So this you only need to do if you're doing it on a GPU based machine. So if you're not doing this on a on a machine that has a GPU, you can skip this step. What we're effectively doing here is we're limiting how much VRAM TensorFlow can use on the GPU, because by default TensorFlow is going to expand to take it all over. And if you don't go and set this, then you're effectively going to run into out of memory errors. So this helps avoid this. So let's write a comment. So avoid out of memory errors by setting GPU memory consumption growth, right? So think of this think of this as like putting some chains around your GPU to let it go, to stop TensorFlow from going crazy. Or it's more chains around TensorFlow than the GPU, but effectively we're going to be locking TensorFlow down so it doesn't go crazy, right? So let's go ahead and do this. Okay, hold on, we've list fizz. Okay, so that is our memory consumption growth now set. So we've gone and written 3 different lines of code there. So first up, what we're doing is we're actually accessing all of the different GPUs on the actual machine. So if I actually type out GPUs, you can see that we've actually only got one there. So if I take a look at the length of that, So you can see we've got one GPU. So in order to get that, we've written GPUs equals tf.config.experimental.list_physical_devices. And then we've passed through a string which says GPU. So what this line is doing is it's actually getting all of the different GPUs that are available on our machine. Then we're actually storing that inside of a variable called GPUs, which is effectively what I'm showing here. All right, so you can see it says physical device name equals /physical_device GPU 0. So this basically means that we have a GPU here. Now in this case, the GPU that I'm using is a RTX 2070 Super. So I think it's got around about 8 gigs of VRAM. So just something to keep in mind, sharing some information, you know. All right, then what we're doing is we're actually going through and we're setting our memory growth. So we are looping through all of the GPUs. So again, if you had multiple GPUs, this is going to work as well, which is why we do the loop. So for GPU in GPUs, so it's effectively just looping through this. So for GPU in GPUs, we could effectively print GPU, right? So we're effectively looping through them. But then what we're doing is we're actually setting our memory growth, which is this function, which you can see right there. So I've written tf.config.experimental.set_memory_growth. And then we're passing through the GPU that we're processing at that time. So if you remember, we're looping through each one of them up here. This is actually going to go and set that GPU and set memory growth equal to true. Got a bit tongue-tied there. All right, cool. So you can see that that is now done. So we're grabbing all of our GPUs, we're looping through each one of them. If we've got multiple, this works. And then we're using the set_memory_growth method to set our GPU growth equal to true. And remember, we're passing through that GPU and passing through true to actually set that. Cool. So we can delete this cell down here. So let's delete that. And that is section 1.3 now done. Now, the next thing that we need to do is a little bit of setup. So we actually want to set up our folder structure so that we are in a good place when it actually comes to getting our data. So if we actually, let me actually show you where I'm working, what I'm working with. So the folder that I'm currently working in looks a little bit like this. So right now I've just got a virtual environment. I've got some Jupyter Notebook checkpoints, and I've got the actual notebook that we're working in at the moment. What we need to do is create a couple of folders. So we are going to create 3 specific folders for our data. We're going to create one called anchor, one called positive, and one called negative. Now let me explain what each one of these is going to do. So if we actually take a look at our neural network, let's see if there's an example of it. Okay, this is a good example. So when we actually go to perform our facial verification, we're actually going to pass through 2 images. We're going to pass through an image called an anchor, which is, think of this as your input image, right? So this is, if we are going and doing it in real time, it would be the image that's captured from your iPhone, or the image that's captured from your webcam, or whatever image that is verifying you in real time. So think of this as your anchor. We then pass through a verification image, or a positive or negative image. So what we're effectively going to be doing is saying, hey, does our anchor match the positive image? So in this particular case, you can see the soccer ball matches the soccer ball, so it outputs same. When our neural network does it, it will output 1. We then also pass through our input image again, or our anchor image, and then we verify it against a negative, and we want to make sure that that is different, because we effectively want our neural network to be able to distinguish between ourselves and another person. So we're going to call the input image an anchor image. We are going to call the verification image, which is positive, the positive image, and we're going to call the verification image, which is a negative example, the negative image. Now, all the negative data we're actually going to get from a repository called Labeled Faces in the Wild, which is a sort of like a standard repository, but we're going to be doing that in another tutorial. I'll show you, or in another episode of this series. But I'm going to show you how to set all that up. So when we actually go to collect our positive and our anchor data, we're going to be using our webcam for that. So again, we're going to be going through that, I believe, in episode 2 of this. Cool. That is that explained. So what we now need to do is actually create some folder structures. So what we'll first up do is we're going to set our paths, and then we'll actually use the OS library to actually go and create those directories. So let's set up our paths first up. Okay, so those are our paths set up, and we haven't actually created the folders there. We're just defining what our paths are going to look like. So this is effectively what our directories are going to look like. I'm calling them paths, but it's just our directories, right? So I've written POS_path, and I've just defined all of our paths in negatives because it just makes it a little bit easier to understand what they are. So POS_path equals os.path.join. So what os.path.join does is it effectively joins different directories together to be able to form a full file path. So what you'll get out of this is data, and then it's either going to be a / or a double / depending on what type of OS you're using. So the file path is going to be data, and then / or / positive. So if I actually take a look at that and type out positive path, you can see this is just returning the file path that we're about to create. And then we've gone and done it for our negative images and our anchor images. So remember, our positive images are going to be our positive verification images, our negative images are going to be our negative verification images, and our anchor images are going to do the same. Now, when it actually comes to implementing this on a real life implementation, I've got a slightly novel or special implementation that we're actually going to use. But again, we're going to do that more later on in this series. But we've got something special to make this actually work really, really well. All right, so we've got positive path, negative path, and anchor path. And then what we are going to do now is create those directories. So let's go on ahead and do that. And let's actually just take a look at the folder. So we're going to basically create one big folder called data. And then inside of there, we're going to have 3 different folders. So one called positive, one called negative, and one called anchor. Now, what we need to do is actually go on ahead and create those. So let's go on ahead and do that. So I'm just going to delete this cell here and then create a new one. Let's do it. Okay, so those are our directories now made. So let's add a comment there, make the directories. So in order to do that, I've written os.makeDirs. Now keep in mind, it is MAKEDIRS, not MKDirs. MakeDirs actually goes and creates all these subsequent folders. So if you don't have a top level directory created, it's actually going to create the full file path. So I've written os.makeDirs, and then I've passed through our positive path, os.makeDirs, and then pass through our negative path, and then os.makeDirs and pass through our anchor path. So we're effectively doing this path, and then this path. Now, if you wanted to, you could put this inside of a list and then loop through them. I figured it's just as easy to do this. But basically, we're going to be creating all of our different directories. So if we now go into our folder, and mine is inside of YouTube and Face ID, you can see, let me zoom in on that so you can see it a bit better. So you can see I've now got this folder called data. And inside of that, I've got 3 folders. So one called anchor, one called negative, and one called positive. There's nothing in there at the moment, but our 3 folders are created. And you can see that we've also gone and created this top level data folder. So everything that we're going to use when it comes to getting our data is going to be in here and then in one of these 3 repositories. Cool. Alrighty. And I think on that note, that is us done. So we've gone and now created our folder structures. So we defined our paths and we went and set up our directories. So we've gone and done a whole bunch of stuff in this tutorial. So we went and installed our dependencies. We went and imported them. We then went and set our GPU growth. And we also went and created our folder structures to get ready to actually start collecting our images and building our Face ID or facial verification model. So on that note, that is this tutorial now done. See you in the next one. Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell, and let me know if you've got any questions or comments in the comments below. Thanks again for tuning in. Peace.